the rest of the semester doing things with derivatives. They have tons of applications. Derivatives is probably the number one reason that calculus is required by so many majors, because it allows you to find a lot of very important things. It allows you to find maximums and minimums, rates of changes, all of these different things. So first thing, if we're talking about tangent lines, we've already been doing that. We know a tangent line is just a line that touches your graph at one particular point. So if I were trying to estimate the tangent line right here, what did we do to try to get a good idea of what the slope of that might be? And that's what we were doing the whole last chapter. You know, when it started out, we said, well, let's take points close to it. And if I took 2 points close, then I could find the slope of those. And then you can make 2 points closer and look at the slope of those. And we made those whole tables to try to guess the slope of that tangent line. Well, that tangent line, the slope of it is really giving us the derivative. So we have been approximating slopes of the tangent lines. Let's say I asked you to find the equation of the tangent line to the parabola y equals x squared at the point 1, 1. Okay, we need that slope of the tangent line. And that's what we got done doing in the last chapter. We could make those whole tables to find it, but then we end up saying, well, that's really just the limit. And then we spent the rest of the chapter figuring out how to calculate those limits. So if I wanted the equation of this tangent line, we first need the slope, which would be the limit as x approached the x value, which the x value of this point is 1. And then we need to set up our slope equation. Okay, I have a point 1, 1. And I want it to be tangent to my graph. So if I wanted to point on my graph, I don't want to call it xy because I don't want multiple variables. So I have x. What is y equal to? X squared. So my point would be x comma x squared. So then the slope between them, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. What do I have to do to be able to evaluate that limit? That's when you're approaching infinity, that we tried dividing by the highest power of x. Factor. We can't plug in right now because we're getting 0 on the bottom. We could write that as x plus 1, x minus 1 over x minus 1. Then those x minus 1's cancel, and then can we plug in? We get 1 plus 1, which is 2. So our slope is 2. Now we have a point and a slope, so we can write our equation. Y equals mx plus b. So our y-intercept is negative 1. So y equals 2x minus 1. That is the tangent line. So look how far we've come. We started several weeks ago, struggling just to approximate the slope of those. And now we know the slope for sure is 2, and we can write the whole equation of that tangent line. There are different notations that we might see for this. Another option that means the same thing has h's in it. So it's saying a limit as h approaches 0, f of a plus h minus f of a over h. It's saying if you took 2 points, the first one being a comma f of a is just what you get when you plug a into your equation. And then if you move over a little distance, you add h to that. Then now you're plugging in a plus h for your x and your y. The benefit of this, if you do the slope between those, you have your f of a plus h minus your f of a over, if you do a plus h minus a, what happens to those a's? They cancel and just gives us an h on the bottom. It's the distance, the limit as h goes to 0, so the distance that we've moved over is getting smaller and smaller. It's also just another way of finding these slopes, but it is a little bit nicer because it's easier to cancel when I only have an h on the bottom versus when I have two terms on the bottom. So it can be a little bit easier to reduce. So I'd like to use that approach to do a problem. So find an equation of the tangent line to the hyperbola, y equals 3 over x, at the point 3, 1, using the second method. So 3, 1 is the point, my other point is x, comma, what's my y? No. 3 over x. Okay, so the slope is the limit. I want the distance between these things to go to 0, so as h approaches 0. F of a plus h. A is your x value. So f of a plus h is saying you plug in a 3 plus h into your formula. So if we'd done it the old way, we would have just done the slope between these two things. But now if I want the a plus h, my a is 3, my starting point. So we're going to plug a 3 plus h in, so that would be 3 over 3 plus h. Minus f of a, that's what you get when you just plug in your 3, which is 1. So my y value, or 3 divided by 3 is 1, all over h. Okay, I want you to take a second and make sure you know where I got all of that stuff. Questions right here. Then we have to simplify this and get our h off the bottom, because right now I can't plug in if it's 0 on the bottom. What are some strategies that we've used? To divide by a fraction, this is like h over 1. That's the same thing as flipping and multiplying, right? Let's see if that will help. So we would have 3 over 3 plus h minus 1 times, whoops, I have to flip that, 1 over h. Okay. Not helping so far, is it? Is there a way I could add these things together? They need a common denominator. So I could rewrite my 1 as what? If I want the same denominator as 3 plus h, it would have to be 3 plus h over 3 plus h, wouldn't it? What would you have to do with that negative? Distribute. So positive 3 and negative 3 would cancel. So we get negative h over 3 plus h times 1 over h. Is this helpful? Why? What happens? The h's cancel. The h on top and bottom cancels. You get negative 1 over 3 plus h, so now you can plug in a 0 for your h and you get negative 1/3. Okay, but I wanted the whole equation. So that's our slope. Plug in y equals mx plus b, so my y is 1, m is 3, or sorry, m is 1/3, negative 1/3 times x, which is 3 plus b. Add that over, so my b is 2. So the tangent line is negative 1/3 x plus 2. We plugged in
Oh,
0.
okay.
Okay, I want to do the same problem but working it the first method as well, just to kind of illustrate the difference. They're both going to get us the same answer. So if we're doing the first method, that's when we're using these points, 3, 1, and x, 3 over x. And so for that one, to find your slope, you do the limit as x approaches a, so as x approaches 3, and you do your slope, 3 over x minus 1 over x minus 3. And so now, what do I need to do? Any ideas? Do we usually leave a fraction within a fraction? No. So one option could be multiply top and bottom by x. So 3 over x times x is 3. 1 times x is x over x times x minus 3. What do you notice here?
Same thing on top and bottom.
They're almost the same, aren't they? What would I have to do to make them the same?
Negative.
Yeah, if I took out a negative 1, then it would be a positive x and a negative 3. Then those cancel and I can plug in, I get my negative 1/3. And then you do the same thing to find the equation from there. You just plug in your point and your slope. So we get the same thing, just two approaches for how to do it. There's not like a given rule that this one method is always going to be easier. It kind of depends on the problem. Sometimes this is faster, sometimes the other one is faster. But I'm just showing you both options there. Typically, we are going to get to the point where we're probably using the second method more often, so the a plus h method. All right, everybody with me so far? It's basically connecting a bunch of dots that we did before. We wrote the equations of tangent lines last little bit, but we had made the tables to get their slopes. Then we learned how to do limits, and now we're putting it together, using the limit to find the slope, and then writing our equation. Okay, we can also talk about velocities. We have kind of touched on this already because we had a question on our test about it. Average velocity is what? A slope. And instantaneous velocity is yeah, just at a particular point. And so to find the average velocities, we could just take 2 points and find their slope. But to find instantaneous velocity, we had to make those tables and see what our slopes were approaching. So this is just telling us the same thing. Velocity is just your displacement or your position divided by time, change in y over change in x. Just speed with direction, so it could be negative. Instantaneous is at a particular point, so that's when you have to do the limit. It's like the tangent line. All right, so let's do a problem. Suppose that a ball is dropped from the upper observation deck of the CN Tower, 450 meters above ground. Part A, what is the velocity of the ball after 5 seconds? And part B, how fast is the ball traveling when it hits the ground? So A, I want the velocity at a given point in time. I want it when the time is 5 seconds. And B, I want the velocity at the point when it hits the ground. Okay, so we have two options for how to approach this. Since I'm asking you to do two velocities, could we maybe find a formula for velocity first instead of recalculating it each time? Would that be okay? So I told you this is going to be the equation for height. So if I wanted to use that second method, we want the limit as h approaches 0. F of a plus h minus f of a all over h. So we could do this once with our a being 5 and then again with a being whatever it is when it hits the ground. But let's just first work this out with a's, and that way we have a formula and we can quickly find our other velocities. So if we do the limit as h approaches 0, f of a plus h means you go to your function and you replace your variable with an a plus h. Minus f of a, so you go to your function, replace your variable with an a, all over h. What do you have to do if you have a plus h squared? How do I do a plus h all to the second FOIL? So if you wrote that twice, you get a squared plus 2ah plus h squared. We distribute. Now what happens?
4 plus 9 cancel.
Add your like terms and those cancel. Everything that's left can be divided by h. So if I do that, I get a 9.8a plus a 4.9h. If I plug in 0 for my h, I get 9.8a. So this is basically my shortcut. This will be our velocity at a given point in time. So then, to do part A, I want my velocity after 5 seconds, so all we have to do is plug in at 5. And we get 49, velocity would be meters per second. Part B, I want my velocity when it hits the ground. So first, I need to figure out when it hits the ground, don't we? The formula I gave you, S was the distance it has traveled. We started 450 meters above the ground. So how far does it need to travel to hit the ground? So we have to travel 450 meters to get back to the ground, equals my equation, my 4.9 t squared. So I'm just solving for my time here. So you divide by 4.9. How do we get rid of a square? Square root. Normally you do plus and minus, but can time be negative? No. And so we get 9.5831. So then to find the velocity, all you need to do is plug that into your formula. So our velocity would be 9.8 times the 9.5831. And we get 93.9144 meters per second. So because I knew I was calculating two velocities, that's why I didn't plug in my time until later. And that just saved me a little work along the way. Alright. questions so far? So what we have just been doing is actually finding what is called a derivative. So that is what we will be asked to find from now on. That's what we've just been doing on every one of these examples. The derivative, the actual definition, is that second form, so that's why we use it most often. The limit as h approaches 0 of f of a plus h minus f of a all over h. And that's something that comes up when we are looking for a rate of change at a particular point in time. So science, engineering, business, if you're talking about maximizing costs, minimizing profits, said that backwards. Minimizing costs and maximizing profits. It comes up, rates of change in a chemical reaction. So lots and lots of applications for this stuff. So that is the actual definition of derivative. The notation, we typically put an F prime, so that little tick mark tells us we're doing the derivative. It is the same thing if I ask you to do the first definition. We just don't use that one as much. So both of those that we were using are derivatives, whichever way you chose to work it. All right, let's just find some derivatives then. So I want to find the derivative of this function at a number a. All right, so I didn't tell you what a was. That means we're essentially finding a formula for the derivative. So derivative is the limit. Let's just use the first definition as h approaches 0 of f of a plus h minus f of a all over h. So f of a plus h, if I go to my function and I plug in a plus h, a plus h squared minus 8 times a plus h plus 9 minus f of a, if I plug in my a's, so what do I need to do to square the a plus h? FOIL, so that would become a squared plus 2ah plus h squared. Is everybody understanding where I'm getting that? What do I need to do with my minus 8a plus h? Distribute the negative 8, so minus 8a minus 8h plus my 9. For this one, we can distribute the negative, so it becomes a negative a squared, positive 8a, and a minus 9. From here, what happens?
A squared cancels, a cancels,
And everything that's left has an h in it, so we could divide an h. So we get 2a plus h minus 8. And if I plug in a 0 for my h, that gives me 2a minus 8. So this is the derivative. That's the slope of the tangent line. So if I wanted the slope of the tangent line at 1, what would it be?
2a,
My a would be 1. So it'd be 2 times 1 minus 8, so negative 6. If I wanted my slope when a is 0, it'd be negative 8. Think about when we started, guys. For every one I gave you, you had to make 2 tables and look at the values it was approaching. So we have taken that. If I wanted 3 different values, you can give them to me in a matter of seconds now. Where before, if I'd wanted 3 different values, you would have been making 6 different tables to try to approximate those. So we've come a long way. We're saving ourselves a lot of time. Alright. So that's what the next thing just tells us, that the derivative is just the slope of the tangent line. So f prime A is slope of a tangent line at x equals A. So we no longer have to make tables to approximate these. We can just do our derivative. Let's look at another one. So this was the one that we just did the derivative of. And we found that the derivative, you can call that y prime if you want, the prime just means derivative, was 2a minus 8. That's what we found on the previous example. So if I wanted the equation of the tangent line at point 3, negative 6. To find my slope, what do we do? What's my a? It's just your x value, so a is 3. Plug a 3 into your derivative, which is just the slope. So we get negative 2. So now we have a point and a slope. We can write the equation. Y is negative 6 equals n negative 2 times x plus b. Add that over, so you get your b is 0. So the slope of the tangent line, or the equation of the tangent line at that point is y equals negative 2x. How far do I want to go with this? 2 years. Want me to do any more, or you want me to stop today? Let's stop. We're going into the weekend. We're going to stop here. So, the homework from this section is all right here. We are going to spend Monday, I will probably finish up the notes, so then we should have Tuesday for class time to work, so this will not actually be due until Wednesday. So we're going to still be on this